Okay guys, I'm going back, second attempt to explain certain questions better, okay, because I've seen my own videos and they're horrible, so some of them. So like number one, for example, it requires more explanation than what I gave on the first video. It says, identify the leading coefficient. That's easy. It's the number that's out in front when it's in standard form, when it's in order from highest degree, highest exponent down to smallest, down to constant at the end. So leading coefficient is -5. The degree is the highest exponent, which happens to be 5. Now the interesting part is the end behavior of the function, okay? So we know that the leading coefficient is -5 and that the degree is 5. Leading coefficient is -5 and the degree is 5. We already know that. But what we need to really understand is the end behavior. Let's take a look at some notes I have right here for us. So whenever you have an even degree function, it's going to have the same end behavior as the simplest type of even degree function, which is a parabola. Now I see the parabola has the end behavior up here to the top left and top right, unless you actually have a negative sign in the front, which would be the example of this one, which is in red, and that's why it's opening down. The end behavior would be down here. So a parabola, or an even degree function, any even degree function, x to the 4th, x to the 6th, x to the 8th, is going to have end behavior up here. Unless your a value is negative, then it's going to have the end behavior down here, okay? And an odd degree function, any odd degree function, whether it's 3, 5, 7, or 9, is going to behave exactly, it's going to have the same end behavior as a cubic function, which is a snake-like curve. And to be more specific, if it's a positive a value, in other words, y equals positive x to the 3rd, it's going to have what we see here, this black curve. The black function is represented with the black snake-like curve here. Okay, now, what if you had a negative out there in the front, a negative a value? Well, here it is, negative a value, which is a negative x to the 3rd, and that's going to cause this end behavior to reflect, right? So you have this end behavior and it reflects to this end behavior. So I hope that makes sense. I hope it helps you out. So any even degree function is going to have this end behavior or this end behavior. Any odd degree function is going to have this end behavior or this end behavior. Now obviously on our test we know that it's the degree of 5, so we're going to have this end behavior if the a value is positive. So if we go back and look at the a value is -5, so it's actually reflected on the x-axis. So the a value is negative, which means it's this one, which means it has an end behavior up here and down here. So think about that, guys. This is going to be our answer, up here and down here. That's our end behavior, okay? Now, in addition to knowing this stuff, you need to know the notation of end behavior. So what I want to do right now is simply, I want to cover up this over here. Let's just, for the purpose of getting better at end behavior notation, let's take a look at this first one. As x approaches positive infinity, keep in mind that your x-axis is the one that runs left and right. So if it says, as x approaches positive infinity, if you're at 0 on x, 1, 2, 3, 4, positive infinity is this way. So as x approaches positive infinity, that means as you go this way, or in other words, as you go to the right, where's your graph at? Well, it's going up there. So as you go to the right, your y values are going up to infinity also. So when you read this, as x approaches positive infinity, your f of x values, which are really your y values, also go to positive infinity. I hope that makes sense. Now, if you take a look at this next one, it says, as x approaches negative infinity, what does that mean? Negative infinity is this way. So in other words, as x approaches negative infinity, that means as you go to the left, where's your graph at? Oh, it's going up forever, right? So as you go to the left, as you approach negative infinity, your f of x is positive infinity. And looking at the red one, obviously, as x approaches positive infinity, where are your y values? It's down here. So as you go to positive infinity, you're going to negative infinity. And as x goes to the negative infinity, well, you're also going to go to the negative infinity. I hope this helps, just to help you out with the notation. And, whoa, that's not good. Give me a second. So if we take a look at this other cubic function and we talk about the notation for end behavior, as you go to positive infinity, that's what it says here, as you go to positive infinity on the x, where are you at? You're going to positive infinity on the y. So you'd have a positive infinity right there. Okay. As you go to negative infinity on the x, you're going to negative infinity on the y. So it's also negative infinity right there. Okay. If you look at the red one, as you go to positive infinity, that's saying as you go to the right where your y value is at, they're going down to negative infinity forever. And as you go to the negative infinity, that means to the left, your y values are going to positive infinity. So that was just a little exercise to get you guys more comfortable with the end behavior notation. So let's go back to the question itself. Now we know that it was an odd degree function. It's power of 5. So we already know that the end behavior is over here and down here. So what does that mean? That as x approaches positive infinity, f of x approaches negative infinity. How about up here? As x approaches negative infinity, f of x approaches positive infinity. So once again, let me just put that right there so you could see it. No, that's not going to work out. I'm going to put this over here. So, if we read right here, as x approaches negative infinity, p of x approaches positive infinity. That is correct. As you go to the left, it goes up forever, right? And as x approaches positive infinity, p of x approaches negative infinity. As you go positive infinity on the x, it definitely goes negative infinity on the y. So your answer is B. I hope that makes it crystal clear how to do numbers 1 and 2 on the practice test. Let me go back and try to explain number 19 even better than on the original videos. Number 19, you want to evaluate log base 9 of 243. It's always good to know how to evaluate logs. For example, if you have log base 2 of 8, what you need to think is that base down there to what power gives me 8, right? So in other words, 2 to what power? 2 to what power gives me 8? And the answer is 3. So you know that log base 2 of 8, the answer is 3. Boom. Done. That's the way it works. So on number 19, what you're supposed to think, well, first try to do this in your head, and you're thinking, okay, 9 to what power gives me 243? 9 to what power gives me 243? Well, I know that 9 squared is 81. And 9 to the third, 81 times 9, I don't really know. Let me do that on the calculator really quick. 81 times 9, and we get a tremendously huge answer, 729. Okay, so just to let you know, this one right here is 9 squared. That's how I got 81. This one's 9 to the third. That's how I got 729. Okay, so I don't want 81 or I don't want 729. I want 243. So logically, if 9 squared gave me 81, which is too small because I want 243, and 9 to the third is 279, which is too big, then what must our answer be? Well, it can't be 9 to the third. That's 729. It can't be 1.4 because that would mean that my answer would be less than 9 squared. 9 to the 1.4 has to be less than 9 squared. So it does have to be a value between 2 and 3, so it would be 2.5. That's one way of doing it, okay, that I didn't explain before. So let's try another option, okay? Like let's say you don't want to think that much. All right, so what could you do? You could just rewrite your exponential form, change the logarithmic form to exponential form. That's saying 9 to what power equals 243. Now you are able to use a calculator, so all you got to do is take your calculator, type in 27 right there, and check and see if it gives you 243. It won't. That's going to be a huge number. Type in 2.5 right there, 9 to the 2.5. It will give you 243. Okay, so you could also guess and check that way. Anyway, let me see what else we could explain.